This video features the solutions to the Algebra 1 mixed review, questions 1 to 15. Question 1. Which expression is equivalent to 3 to the third power times 3 to the fourth power? Since we're multiplying powers here with the same base, we have to remember that the rule is to keep the base and add the powers. So 3 plus 4. And this would be 3 to the seventh power. Number 2, which expression is equivalent to 3x squared cubed? So we are raising a power to a power. When that happens, we multiply the exponents. Another thing to realize is that we have to also cube everything in parentheses. So the 3 is going to be cubed, and then x squared in parentheses also has to be cubed. 3 cubed is 27, and over here is when we use the power to a power rule. We keep the base as x, and we multiply these powers to be a 6. 27x to the 6th power is the right answer. In number 3, we have 2 to the negative third power, which is a negative exponent. When you have a negative exponent, you have to take the reciprocal of 2 to the positive third power. And that would be 1/8. And you could expect to have a fraction answer or a decimal answer when that's the case with a negative exponent. Number 4, we have another negative exponent case, except we're having a variable x to the negative fourth power. This would be the reciprocal of x to the fourth power, which would be 1 over x to the fourth power. In number 5, we have 3 to the 0 power plus 3 to the negative second power. So we have the 0 exponent, and we also have negative exponent. Anything raised to the 0 power is equal to 1, so 3 to the 0 power would equal 1. This is going to be added with 3 to the negative second power. When you have something raised to a negative power, it's going to be the reciprocal of that base to the positive second power. So 1 over 3 squared, which is 1/9. And this would be added to 1 to form the mixed number 1 and 1/9. In number 6, we have an order of operations question. (15 minus 3), and then we have brackets, which is a grouping symbol, 2 plus 6 times negative 3. So we do have parentheses, which is going to indicate multiplication, but we also have to deal with the brackets. The grouping symbols are always dealt with first. So we're going to bring down 15 minus 3. We're going to open up the brackets, and then we're going to take care of what are in the outside brackets first. Within those brackets, we have 2 plus 6 times negative 3. Multiplication would come first, so we're going to put 2 and then multiply 6 by negative 3 to get negative 18. We're going to continue to simplify those brackets by taking 2 and subtracting 18 and get negative 16. Brackets are a part of the grouping symbols or the parentheses. We don't have exponents to deal with. Next, we would take care of any multiplication or division from left to right. Those are grouped together, and they are handled from left to right in the same way that addition and subtraction are also handled left to right. That's why I'm going to write L to R here. However, there's only multiplication, so we're going to take care of -3 times. Brackets are just like parentheses, they indicate multiplication. -3 times -16 would be 48, and then 15 would be then added to 48, since a -3 times a -16 would it change that middle sign to be a plus. (15) plus 48, 63. That's your final answer. Number 7, which of these numbers is irrational? So an irrational number cannot be expressed as a ratio. Choice A is 5/4. That's a fraction, that's a ratio, so that's rational. B is 0.3 repeating. Repeating decimals are rational. Then you have the square root of 121, which comes out to be 11. Since it's a whole number or an integer, that's rational. And the reason for that is because 121 is a perfect square. When you take the square root of a perfect square, you will get a rational number. However, pi is irrational. That will always be irrational. Number 8 is similar. We want a rational number this time. We just saw that pi was irrational. The square root of 3, that's the square root of a non-perfect square, so that's an irrational. Then you have the square root of 7. Again, 7 is a non-perfect square. When you take the square root of a non-perfect square, that's also going to be irrational. And if we take the square root of 16, 16 is a perfect square. That comes out to be a 4 when you take the square root of 16. So this is a ratio. It could be expressed as a ratio, so that is rational.